Welcome to the third day of Spring 2020, the very first edition you can enjoy remotely, basically all over the world. My name is Urs Peter and I will be your host today. Today we have another two distinguished talks with very interesting speakers. And to keep these sessions as interactive as possible, I would ask you to use our chat function right away through jspring.nl, or if you want to have a more advanced chat experience, simply click on the Discord button above our chat widget, which will bring you to various chat rooms where you can talk to the speaker and also to our sponsors. Don't forget to follow the NL Chuck Twitter, our LinkedIn group, and don't forget to subscribe to our LinkedIn channel. I would like to thank our sponsors to make Spring Digital possible. And if you want to talk to them, go to one of the Talk To channels in our chat application. Okay, then now I'm very pleased to announce our first speaker, Brian Vermeer, Develop Advocate for Sync, Oracle groundbreaking ambassador, co-lead or leader of quite some community groups, and a frequent speaker on the big Java conferences, which will enlighten us with his talk about Know Thy Neighbours, dependency management done right. Enjoy.
All right, thank you, Urs. Well, as you can see, I love the picture that was there like in the beginning without me having a beard, and you see what Corona does to you, right? I mean, for some people it's for the better, for some people it's for the worse. I'll leave it in between if that's either of them. But anyway, I'm going to talk about dependency management today. So welcome, but let me first tell you a story. The first story I'm going to tell you is, as you can see on my first slide, is about software development. And well, let's say it's software development lifecycle, right? I'm going to change my screen for a bit, so I can see the next one. Anyway, say you need to develop a program, and for instance, how does it always start? It always starts with a POC, right? You have this small thing you want to try out, or your product manager comes to you and he wants to try out some things, and he will ask you to do a small thing, very scoped, very, very, very small, and very, well, clean, basically. So say we bring that into a drawing. And you know I'm a very good drawer because it's a very scoped thing over here, right? It's a very small shed, maybe for your guests to stay in. But it's the same with the software development lifecycle. You build something small, scoped, very neat, and you try it out. And then always what you know with POCs is like, if it's in production and it works, it's never really a proof of concept, right? If it works, we keep it in production. But fair enough, it works. It works perfectly, let's say, because we're all Java developers, we have a great ecosystem, we have great people, of course. And then there comes that product manager again to you, and he says, well, you know, this works great, but you know, if we can just adjust a little bit and make this possible as well, and you're like, hey, we're agile. We're trying to make things right. We can deliver fast and frequent. So then you build this little thing next to it. Still good, still within scope, kinda. and that works perfectly. You push it into production, and then it comes that the upper level management hears of your great POC, which drives a lot of attention and maybe some revenue, and then it comes to the point that they say, from a business perspective, we want to add some features to it. But actually, if you look at it from bottom up, the foundation is not really meant to build new stuff upon. Basically, you would say, if you do that from the beginning, maybe we should do that in a different way. But fair enough, with a little trick and a little hack over here, it ends up like this, right? You studied somewhere, you put something on top of something, and it works because, hey, it's like software, and it worked before. Why shouldn't it work now? That's how the business thinks. And you know what happens? If you give them that one finger, they will take the second one and the third one and the fourth one and your whole arm, your legs, and they try to shove in new features, and you will be basically restructuring some things, but you haven't got the time to rebuild it from the bottom up. So it will be ending like this, with some dirty hacks and some actual patches, which you probably annotate as maybe we should do this later in a good way as a to-do, but you never come to it, and it grows and it grows and it grows, and it ends up like something like this, like one system to rule them all. We want to fly helicopters, we want to talk to space, and that's how software development nowadays works. Because do we have time to build all these things? Think about that. But first, who am I? Well, you already heard, I'm Brian. I'm a developer advocate for Snyk, and Snyk is a, well, let's say software security company. We build secure, we build tooling to make you develop in a more secure way. Well, I do some stuff with some jugs, Oracle Groundbreaker, all fun, but this is the most boring slide ever. Because we are going to talk about dependencies. Because most of the things that we want to achieve, we don't build it ourselves from the bottom up, right? Yeah, we do, but you probably know this one. If you build a Spring Boot application, what's the first thing you do? You go to Spring Initializer or any other scaffolding mechanism. I mean, if you look, use Quarkus or Micronaut, they probably have scaffolders as good as these ones as well. But you know what I get, right? You don't want to do all the boilerplate work. And you just click and drag and drop and see what version you want to have. And then you end up with basically a fat jar. Well, let's get into that fat jar. Say this is that jar that you put into production. Think about what is the actual code, specifically the lines of code you write. Not that much, right? It will probably be something like this. Oh, I'm going way too far. It will probably be something like this. It's just a small amount of business logic that you develop. The rest is based upon frameworks, libraries, and these libraries depend on more libraries, getting more libraries in. So we do care a lot about our own code because we all have things like pair programming, hopefully, or code reviewing. But how do we care about these dependencies? That's what I'm going to talk about. So I did something before this talk, and what I'm going to do now, I'm going to show you something. So we have this Spring Initializer app, right? And we can create an application over here, and I already did it for you because, well, normally at conferences, internet connections are not that good, except for here. So go for virtual conferences. So I created an application, and this application, let me just minimize this one. It's over here. And you see that it's a zip file, and I unzipped it. Nothing more, nothing less, right? I already did that for you. So what we're going to do here, let me get to the right one. That's this one. And this is just a Spring scaffolding application. It's just the scaffolding from Spring Boot with WebMVC. And I created a test controller. So if we look at the POM file, it hasn't much. It's Java 11. Spring Boot test, some vintage JUnit, and of course Spring Starter Web. Cool. I created a test controller, which basically only tells you hello JSpring. Well, I don't have to demonstrate this because we already know if it's just this, it works, right? That's the cool thing about these scaffolding mechanisms. And these mechanisms, these frameworks like Spring Boot or Micronaut or Red Hat, Quarkus, whatever. The point is, the only code I wrote was basically this. So with an annotation, it's 1, 2, and you cannot even mention the last one. So basically, I wrote 2 lines of code. Well, I wrote another application yesterday, and this application is called a line counter. And what I'm going to do here is I'm going to get the jar that is in that target folder I just showed you, and I'm going to deconstruct that stuff. What I'm going to do here, I'm going to unpack the full jar and unpack all the jars in it, walk over it, unpack everything, and unpack all the dependencies. And then I'm going to decompile it. And then I'm going to count the lines of code that are there in my full jar with where I only built 2 lines of code. So let's do this. What it does over here, after every 100 files it comes through, it will show how many lines we are there. So it's not the best code, trust me. It is just a quick application I built just to make a statement. So as we can see here, and I will enlarge it, we already have 33 jars and about, well, almost 10,000 class files. Well, these warnings are from the decompiling library, and after 100 files, we are at 6,200 whatever lines, and it grows quickly. So after 200 files, we are at 25,000 plus, etc., 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 etc. So you see, with those 2 lines of code, you put a bunch of code into production. And at the point when you scaffold it, it's probably a good thing because it was clean, it was probably the newest version, there were probably no mistakes in it, maybe not even some security issues. But what you know is that the same over time because you build on top of it. You're never going to break it down into a new scaffolding part where you build it up from the bottom up, right? Let's leave this one for now. So let's go back to an application and I will show you some numbers because I did it before with another application. This was a Spring serverless application with 222 lines of code. It had 5 direct dependencies, and these direct dependencies ended up in 54 dependencies. Bottom line, the amount of lines of code that went into production were almost 50,000 lines of code. This was something one of my coworkers, one of my colleagues did a year ago, well, maybe a year and a half ago. He did it basically on the same way, and now I tried to create a tool out of it. So let's see what our Spring Boot application does at the end. The point is, if we pick our dependencies, because Spring Boot is just, in this case, in this example, is just the one thing. But we're not there yet, right? We need to build other things. We need to pick other things. We do not want to worry about boilerplate code. So we pick more dependencies to do the heavy lifting for us. But how do you pick these dependencies? That's the question. I mean, do you pick them blindly? Or are you actually having a strategy for that? Yeah, that's me when it's blinking. I'm changing my screen every now and then. So first of all, we have to look at how good is a package. Like, you can't pick a package because it's on Stack Overflow and it works, and if it's in your application and it's fine, you can ship it. Of course you can. But the point is that package that you pick, is it good enough? Does it actually solve the problem you want to solve, or does it solve it partially? And what do you bring in with it? If you're using a way large library and you only are using 2 classes of it, is it worth it to bring that package in? Think about it. It depends on your context. Do I need the package? Well, let me give you an example on that. For instance, if you want to do some string manipulation, you can take in the whole common slang thing from Apache Commons. But maybe with a simple regular expression, you can do it as well. So do you want to depend on something that you actually do not need because, well, it's just convenience? Think about that as well. And then you need to take care of, if I build on top of a library, how good is it and how future-proof is it? How many people are still contributing on it? Is it still maintained? If a library is already out of date, but it works, should I use it in my POC? Because, you know, a POC is never a POC, right? So check things like contributors and are there regular commits and that kind of stuff. For instance, I'm looking here at Eclipse Collections, which is a well-known alternative for the collections library that is natively in Java. And as we look over here, you see that there are, well, a lot of releases, and there are recent releases. Every year there are 2 or 3 releases, and in 2020 there were already 2 releases. So we can actually say, yes, it is well maintained. So that means if something goes wrong or there is a problem with it, maintainers will be there and fix it. And if we look deeper into that, for instance, we look at the GitHub repository, we see that exactly the last commit was done a few hours ago. There are 66 committers, as you can see well on your right-hand side, and they often commit to stuff. There are a bunch of open issues, there are a bunch of branches, but you know they're actively working on it. So basing your stuff upon this one can be a good thing. Although, does it fit your application? That's the good question. Because if you look at the size of this package, it's a package of 10 megabytes. And you can say, well, what's 10 megabytes? I'm building enterprise applications. That's fair enough. But if you're building microservices and you need to take care of memory and you want to reduce footprint, and you're only using, for instance, one instance of a primary library or primary collection, or for instance a tuple or something, and that's the only thing you use, is it worth it to bring in the whole package of 10 megabytes to do it? If you're depending heavily on it because you say, well, for instance, Eclipse collections is one thing that can benefit my performance can benefit from it, then it might be a good decision. But if it's only one thing you use, are you want to use it, or do you need just to upgrade to newer Java versions, for instance? Do I need all of it? Right? Bringing in a library brings in a lot of fuss, and it's already there. But do I need it? Well, you have made that decision. You have built your application, you thought of these things, and then you're done, right? We push to production and we go on with the next project. Well, it's just like your operating system. Every once in a while, your operating system is blinking on you and says you need to update. And most of us do that little gray thing there, update later. Well, from a security point of view, I would say that's not good. But hey, who am I, right? But how about your dependencies? Think about it. How do you update these dependencies? Well, again, we need to think of how these dependencies work. For instance, dependency health. How important is dependency health? What is dependency health? Well, dependency health is for one reason, it is the amount of maintainers and the amount of releases. But also, are there problems with these dependencies? Are there issues with these dependencies? And are these issues being resolved? And these issues can be either security issues or issues like it doesn't work with this and this framework. But also look at indirect dependencies. It's not only the dependency you depend on, but it can use other packages that might have issues. So again, you have to iterate to that same number of reasons why you picked that one, but you have to do it all over again. For instance, if I build a application based on, say I want to do, how do you call that in microservice when you cut that stuff down? If you short circuiting, and we use Hystrix for that. 5 years ago that would be a perfect reason to do that, but at this point it's end of life, right? So should you be using Hystrix, or is that your cue to move on and implement another library or use another library? You can choose not to, but the point is, if you don't do it now, you will basically create technical debt, and you will make it harder and harder and harder and harder. So updating, you can use your package manifest. You can use your package manager to do the heavy lifting for you. So I'm going to show you something again, and you see it's still running. We're at already over the 400,000 lines of code. Anyway, I have a small application over here, and let me just show you the POM file of this application, because that is the interesting part. This POM file contains basically, I think it is 4 dependencies, right? You see one, it's Eclipse collections. Well, again, Eclipse collections, the one is the API and the collection itself. It uses an H2 library, it has Lombok, and it has Apache Commons Lang. That are the dependencies. And I want to know, I'm using these dependencies, and are these dependencies still up to date? Well, let me look. So I can use the versions plugin. So for instance, I use versions and I say something like, what is it? Display dependency, not plural, updates. If I do it like this, Maven will go to my dependency tree. Oh, I made a typo, I guess. Well, luckily, I have it over here. just to make sure that I do not mistype during a live session. Well, what you can see over here is that it has four basic dependencies. And all these dependencies are out of date. And it already shows me that there are newer versions of these dependencies. And these dependencies are, these are just minor upgrades. But then you have to think of that. It is up to you if you want to upgrade. If you do it now, the upgrade will be small. If you postpone it and you postpone it again and you postpone it again, you will face a large task if you need to do it again. I was in a company, I say it's almost a decade ago, and at that point, I think Java 8 was already released for 3 years or something, and we needed to migrate from a very old Java 6 application to a Java 8 application, and that means that everything needed to be updated. The Hibernate layer, the Spring layer, so basically we had to cut open the whole application because it was monolithic, and we had to replace everything and solve every single bug. So if the upgrade is small, you should be able to do it right away. And why not? If it's not breaking, if it's not a breaking change, and you all have tests, right? You all have good tests that test end to end, then you might be perfectly fine. And again, I do this by a command line tool, so I can automate this. Why not do this during every build? Why not just fix this one in and you see every release, you see that, oh, we can upgrade some certain things, let's put that in our backlog. So automate these things. You can basically do the same with Gradle. I have here you see the Maven command, but we also have something similar for Gradle. And I'm just keeping it to Maven and Gradle because, and who uses and, right? No, I'm kidding. Not judging at all. Anyway, there can also be an issue with your dependencies, right? It's not just you need to upgrade because you want to upgrade. And these issues can be, well, these things can be severe. For instance, if we look at vulnerabilities that are identified over the past couple of years in different ecosystems, you see that the blue top line is Maven Central. And within the year 2019, so last year, there were over 400 new issues reported. This is a graph from our new State of Open Source Security report. This and will be released probably somewhere early next week. So if you want to know more, be over there. But you see that every year a bunch of vulnerabilities are found in third-party libraries. And if you look at these libraries, and this is again a graph from that same report, you see that in the middle we have that bar from Maven Central. Almost 3/4 of the problems are not the top-level dependencies, but the dependencies somewhere in the tree down below. Let me look at the time. Oh, I've got plenty of time. Plenty of time. Let me show you what can happen. Yeah, this one. And some of you might already seen this demo, but say we have a very small Spring application over here. And the Spring application is using Spring Data REST, as you can see in this REST repository over here. And it doesn't do much, right? It's just a grocery list. And if you look at this grocery list, you will see that it just insert beans, milk, bread, and sausage for a certain price. We're using Spring Data to do the CRUD functionality for us, and we're using Spring Data REST to make sure that it's a REST endpoint. Well, as you can see, the domain entity is not interesting. But let me just show you how this works. Let me run this one, and we have to pray to the demo gods every time that this thing runs. And oh my god, it looks like it works. So, say I go to localhost 8080. Cool. And you see I have a help browser just to show you what happens over here. If I go to items/1, and I fire this request off, you will see I have the first item in my grocery list. Again, it's not very important, but that's also not the point. That item/1 is an endpoint that is created for me. And we also can do things like that find by name, because that's a CRUD entity or a CRUD functionality that I create, that I automatically create into a REST endpoint, which is cool. And you see I now can get my beer, which is $5.99. But that's not the point. That is how it's supposed to work. The problem is in another thing. As you can see over here, let me just use this stuff. Say I'm doing a curl patch request to this specific Spring application, and it's using a very outdated Spring Boot starter it uses. And what it does, with this patch request, I insert a JSON body. And with this JSON body, I'm able to utilize the Spring Expression Language, SPEL, right? And with that expression language, I'm allowed to interfere with the objects that are there. For instance, I can access the getters and the setters, but I can also create new things. And what I'm doing here is I am creating a new runtime, for instance. And what I try to do this, and I give this runtime a certain, I will execute a certain command on this. So I get that runtime, and I will execute env, which basically gives you the environment variables for the system it runs on. But I can do anything that I'm allowed to with that user. And I fire it up on that item/1. It's just an endpoint that is there to give the first item of my grocery list in this case. And if I do it like this, you will see that you will now have access to the environment variables of my local system, which is scary, because if I can do an env command, I probably can create and delete files. I can interfere with files. And this is because I didn't update and I'm using a very old snapshot version of a Spring Boot starter. But hey, it worked. Never touch it again, right? Not so much. And what can we do about this? Well, let's get back to that application I just created for us, right? So we have this this very small application over here, and maybe I have it in my IntelliJ. Let me just open it over here. File, open recents. Let me get that demo application. And what I can do over here is I can scan it, for instance. What I can do over here, for instance, what I want to do here is I want to scan it while I'm building it, which is a good thing. So let's use a Maven plugin to do this. And I'm using, of course, the Maven plugin from my own company. So by doing this, I'm just putting it as a plugin into the plugins. We are already at 126, trust me, I know. And I need to create a token. I have an account, and let's create a service token specifically for this, because, well, if I use my real token, then you're all allowed to do this, and that's not the case. Although you can do this by just signing up for a free account. So I'm using this token, getting back over here, putting the token over here, and I can actually do something like I can let it fill on, for instance, if there is a medium severity, or if there's a high severity. Or I can say just false, and it just gives me information. I can do a snic test and a snic monitor. Let's do the snic monitor on package, because I'm not installing a Spring Boot. Whatever. And just do it like. Cool. So what I can do now, if I did get my terminal over here, I can do something like, oh, I cannot enlarge this one, unfortunately. Well, let's do it over here. I have this this demo over here, right? Cool. Let me see if the POM file is still okay. If it's over there. Oh, this is the other application. Oh, man, I'm screwing up here. I'm screwing up. Nevertheless, let's go over here, and I can do something like Maven sneak test, and it will test as an endpoint. There are no problems over here, which is fortunate. But I can also make sure that it now runs as part of my test goal. And running it as part of my test goal means that every time I build this, and when I test it, I also test it for vulnerabilities within the application I'm using. Another thing I can do is I'm using I have the CLI over here. Oh, I have the CLI installed over here, and I can do something like sneak test, and I can hang it on my in my CI system. And every time we build something, we see we have vulnerabilities. In this case, I only have some licensing issues, which is not a problem in this case. So don't care, move on. Anyway, we have to scan on a regular basis, and we have to make sure that every time we bring something up and every time we push something out, that we are secure with it. But at that point, we are not there yet. Let's do this over time to make sure that the packages we are using are not vulnerable in the meantime, between publishing and now. Because what's safe now can be harmful later. Moving on. So, then we come to the point when to remove dependencies. Well, this is something that's interesting always. I mean, I've worked for companies where there were POM files, and I'm sorry, most of the companies I worked with Maven. There were POM files that were just growing and growing and growing and growing and growing and growing, and nobody ever cut something out. So we can go on until your disk is full, but that's probably not the way you want it, right? If we have code we do not use anymore, you probably cut it out as well. You do some sort of dead code analysis, or you have a tool for that. Well, if we want to remove that, we can do that as well. I mean, if you have a POM file that is like this, and this POM file is, this is line 977 to 1023, and it's just a snippet of the dependencies that are in. And it was from an application that I worked on years ago. And the issue was there were 3 different XML marshallers and unmarshalling libraries in that. Because people were building on top of things that are on top of that, and they were not aware of what was already in there, if they could reuse it. But no, I'm familiar with this one. So we had 3 different flavors of XML marshalling, for instance. Would you say that's a good practice? I wouldn't. And do you know if all these dependencies are still used? As I showed you over here, it can be that you have a dependency in that might have problems, for instance, or might not work with something. And if you don't know if it's still in use, why do you have it? Honestly. Well, if we look at it, we can do something with Maven again, and I will show you. Say, let me clean this one up. Say I'm looking at my Maven file, and again, you know we have 4 dependencies in this. That was the 2 from Eclipse Collections, the Lombok one, the H215, and Apache Commons. Well, what I can do, I can use the dependency analyze tool within Maven, or the dependency analyze plugin, to see if the dependencies are actually used. So by calling Maven dependency analyze, it goes through my Maven file and it looks if there are dependencies that are unused but declared. And we see over here that I have 3 dependencies that are not used. That's the H2, that's Lombok, and that is the Apache Commons line. Well, the problem is over here. My H2 library is a test library. Of course it's not used. It's only for test purposes. Because what this dependency analyze plugin does, it basically looks through your code, creates some sort of call graph, and sees if a package is actually called from your source. And if it's not called from your source, and it's directly declared in your Maven file, it will end up here as unused declared dependencies. Well, I don't care about the test part, because that's not the part that goes in production. Also, this one is a provided dependency. It's not so interesting as well. The only one is over here. But you can imagine that you have a large POM file over here, right? So what I can do here is something like, let's do, what is it? Ignore non-compile. And I will only have the dependencies that are in the compile scope that are declared but not used. And in this case, I declared common line 3, but it's not ever used. So I can remove it. Be careful with this one though. For instance, Spring Boot starters are most of the time, I don't want to say always because I'm not sure, most of the times are empty jars with a POM file connecting to other jars. Of course, they will end up here as well because, well, basically they are not called, but they're used to bring other parts in. So you still have to use some common sense to do this, but it can help you at least to find out if there are dependencies that are there but not used anymore by your code. And if you have enough tests in place, you can remove them, test if your end-to-end stuff still works, and you can remove them. And you clean up your POM file, and it will be nice and small and fuzzy and cozy again, instead of huge and unreachable, and I have no clue what I'm doing, just add another, right? This is how we do it in Maven. So we use the dependency analyze plugin for this, and with the ignore non-compile, we can make sure that we only see the stuff that is, well, that's not in test scope or not in provided scope, but only the stuff that is in compile scope, or, right? In Gradle, you have to use another plugin. For instance, there are multiple plugins to do this. One of the things you can use is a Nebula plugin, which can basically do the same, and you can use the linter rules to watch if there are unused dependencies. So, a small recap. I'm great on time. The point is, we did all of this, right? And most of the things can be done with tooling. And that is the last point on this recap, as you can see. Use automation to help with all of this. I mean, we do not want to have the burden of test it once again, everything manually, but we want to use it automatically. We want to automatically be pinged if something is wrong. So why not use these tools and make sure that these tools are working for you and ping you every time you create a build, or you create a release, or a release that you're about to release, say for instance beta release. Do what works for you, but there are a lot of tools that can help you with that, and use them in the right way. Don't just use Maven as a Maven clean install, because that is, every time you do that, a kitten dies. Use that in the right way and know how your tools work. And if it's Maven or Gradle or whatever tool you use, look into these things. First of all, if you pick a dependency, make sure that you pick it for a good reason. That seems so obvious, but in many cases it's just, hey, I found this on Stack Overflow and it works. That is not a good reason. That might be part of a good reason, but we have to look at more. Is this actually doing what I want to do? Do I need all of this? These kind of things. Check the dependency health. Check if the dependency is still maintained, if there are enough contributors. If there are just one contributor, don't bother doing that, not in an enterprise application. Because if that contributor stops working on it because he doesn't feel like it anymore, you're screwed, or you have to do it yourself. That's a fair thing. But then you can say, maybe I can build it in such a way that is perfect for my application and open source it. That's the other way around, so you create your own dependency. Scan for security issues often. I showed you a small thing, and I showed you some tooling that can help you, for instance, a Maven plugin or whatever. But why not scan, for instance, with every build? Like you do your unit tests, why not just test for malicious packages, malicious dependencies? Also, you have to look at your own code. But we saw that these dependencies and frameworks have a lot of stuff, or take on most space in the jar that you actually put into production, right? I would say, as a best practice, update often. Because if you update often, the incremental updates will be kind of small. And if something breaks there, you won't have a lot of issues by fixing that. Just like if you saw Tricia's talk yesterday, she also suggested that you move on every 6 months to a newer version of Java, to make sure that instead of waiting for an LTS, or, well, even skip over an LTS version, because going to major versions might break API, might break changes, and you can also already feel if there's performance increasements in that. People and OS maintainers want to make stuff good. That's the reason why they do this. They want to make the world a bit happier and a bit better than it already is, right? So what they try to do, if there is an issue, first of all, report it, and try to work with them or let them work on it so they can fix it. If there is a vibrant community around a package, they will. So if you update often to newer versions, the effort you need to spend on it is not that big. If you wait until you are two major versions later, then you have a bunch of problems, and you might have problems that are coming from other sites as well. Remove unused dependencies. Just like you need to remove that code, if you don't remove dependencies, it's very clear, but remove them. You do not want to have to maintain the stuff or bring in stuff that you're not using. It might be harmful in some ways even. And last but not least, what I already told you, try to automate as much as possible and try to make sure that you get pinged actively instead of searching for things actively. Well, that is about my call and everything I wanted to say over here. If you have questions, please put them in the chat, and I will have a talk with Urs on what questions already came in. I can talk on this like for hours, and there are a bunch of tools that can do much more. But I want to keep it concise because I love the interactive part of this virtual conference so much. So I want to know if there are questions, Urs.
Thank you, Brian, for your inspiring talk.
Thank you.
Definitely, there were some questions asked. Let's start right away with the first one,
yeah, sure.
Which I also personally think is quite interesting. You said that you have to be very careful when picking an open source library.
Yes.
The question which is asked by Bram is, what kind of measure do you apply, whether it's a good or a bad library? So he said things like, you look at how many transitive dependencies you have, you look like how many times it's downloaded, how many maintainers there are. What kind of measure do you apply to know that you're on a good
Very good question. The level of indirect dependencies, of course, is an issue. But first of all, I'm playing the consultant card over here. It depends. It always depends on the context because there is no silver bullet. That's the first thing. But the amount of indirect dependencies is one thing to look at. If it has a bunch of indirect dependencies, you have to make sure that these dependencies basically are also well maintained. It's not only the top level dependency. You also have to look if these indirect dependencies might have security issues or might have collisions with other packages you are using, because class path collisions or package collision with when class loading is something you do not want. I know a very good talk by Robert Scholte and Ray Chang, who had a talk about this, how to solve these kind of things, and that's actually not something you want to do. So yes, the indirect dependencies is one thing, but it depends on what is the use for that package. If I also use these indirect dependencies, and that can be a good reason to do it. I would say it's not a hard thing. It depends on what kind of situation. Don't bring in well, how should I say it? Don't bring in a truck if I can carry something and move along with a bike, right? It's sometimes it's overkill. Second, things like making sure that there are enough maintainers is one thing that is heavily is one thing on top of my list. I mean, I do not want to be. This is just one package, and probably in my application I have a bunch of them. So that means I do not want to maintain all these packages myself. And if one maintainer falls out, or there are just two, and they happen to be on vacation, and I heavily depend on something like that, I wouldn't say you're screwed, but it's the same thing as you're working in a team with 5 people, and 4 of these 5 people are hired sources, consultants, and all of these 5 say tomorrow, well, I don't like it anymore, I'm leaving. The knowledge is gone, and you depend on them heavily. And then something happens. Of course, then something happens at that point. You can solve it on your own, probably. So I would say the amount of contributors is something, and if it's still actively maintained, these two are very important to me. If there are active, or if there are releases very often, that is something as well. If there are issues, I always look in the issue lists. Are there issues with the libraries I am using? What this library actually is used for? Because it's not that I just plug it into my Maven file and use it. I'm just looking what is the meaning of this library, and then I go on and on. But there's no hard score. I mean, dependency health is not something that is trivial. That depends on the situation. It's a fuzzy answer, but I hope it somehow answers Bram's question. But it's a very interesting one. At least you need to think about that. And you need to, I would say, make sure you have a strategy with your team that you are agreeing on using this package, yes or no.
Okay. So dependencies depend, that's what we can say more or less. Maybe I can ask the question a little bit different. When have for the last time not chosen library? So what kind of judgment you applied to not choose this particular library?
Oh, the last judgment I did was using was a library that was promising because, well, I've also looked at Stack Overflow and had 2 maintainers. It was like, nah, I'm not. If it's just a demo application, I'm fine with that. But it had 2 maintainers. I'm like, no. Then I'm just looking forward, and then I actually found out if I look deeper, there was in one of the libraries I was already using. And I think it was actually one of the Spring libraries you're already using. There was a function that basically already did this, but instead of programming and typing on my keyboard, I actually had to research. And I think people have to research more before they start mindlessly typing or slamming a keyboard. And if you have these things in place, and it will get harder when a company gets bigger. I know that, I understand that. But if you have nothing, it is like mayhem. It turns into mayhem. So you have to think about these things at the very least. But the last thing I did I found it out. I wanted to use a library. It has 2 maintainers. Like, no. And I found out there was already a couple of functions. If I combined them, they did the same, or pretty much the same. So I didn't need it actually, in the end.
I think that's a very clear statement.
Yeah.
Excellent. We also have another question by Jordi Molenaar. He asks whether you have experience with tools that automatically update your dependencies. And he mentions Dependabot. What do you think about them?
Very good question. Dependabot is, in my opinion, is a love it or hate it relationship. I won't say I hate it, but I'm more on that part because I do not like that people automatically update my dependencies. I want to be in charge of my program because in the end of the day, if something goes wrong, I need to fix it. So I need to be confident when something updates my dependencies that it actually is needed. So I want to test it myself as well. I want to at least have feeling with it. And this is not a matter of, again, hard numbers. I would like to have feeling with it. So if there is a new dependency, I want to try it, I want to click it, I want to see if it's still working as I want it to work. Of course I have my test suite, but I still want to use it as a user first before I drop it into my production. So I don't like it. Personally I like it more that Dependabot can create pull requests for you in GitHub, for instance. I like it when it does that. I never merge the pull request. For me, it's a warning sign because it also emails me like, okay, there is something. And I use it as a warning sign. Maybe I should update this. But maybe there's also a point that when is the last time I did update my dependencies? So at least one is out of date. This is for me a cue that to reminder that to look at basically every one of them in that application. And then I will do it manually. I want to test it. I want to have feeling with it. And then I put. But that again is something personal because, well, I like to have feeling with it before I show it to my users.
So the bottom line is that you as a developer want to be in charge, you want to know what you're doing.
Although we program, I do not blindly trust machines.
Okay, J.D. Moller also asked a second question. Do you advise updating to the latest minor or latest major version?
That also depends on what the rest of your application does. So, preferably, I would go to the latest minor. But that depends on how he states the question. Say I am at 3.2, and there's already version 4 out. I would do my best to go to version 4. Why? Probably 3 will not be maintained very long. So, although it can be a 3.3 and a 3.4, and patches will get ported back in, that can be a quick fix. But I would go to to the latest version. If the latest version is already 4.3, for instance, I'm on 4.0 and it is 4.3, I would go to 4.3. Why? These small issues can also be things like performance increasements, or even helping out a security bug. So honestly, my state is try to get to the latest version, but that also depends on how much work depends on that, because it might be that it breaks with other things. So with pulling that newer version in, I might have to redo everything. And in many cases, I don't say you're not allowed to do that, but it's very hard to sell the business like, I need to rewrite it because then it does the same. If you have an architect that knows well that if you don't do that, so it's a cultural thing. If you have an architect that is aware of that you are creating technical debt in that case, he will probably give you some room to do it. But therefore I say, try to update the small deltas as much as possible, so you will not take as much pain as when you wait. Hope that makes sense.
As a summary, try to do major, and in case you run into problems, then do the minors, and make sure that you soon can go to major.
Yeah. Well, even if there is not a problem yet, and say I'm on major 4, and there is a 4.2 or a 4.3, and I see that, and I'm already working out these applications, why not update to 4.3 as well? These minor versions can also fix something. But again, look at what is fixed and not blindly do it. That's why I don't like Dependabot, for instance. I want to know what is fixed. What did this do? Why does a story break or a test break, for instance?
Okay. Thanks, Brian, for this insightful talk.
All right.
So then we will do a short break of some minutes before we continue with our next talk.
Yeah. Which
will be about Micronaut and given by Grim Rocher. So thank once more.
Yeah,
if you have further questions, then we have in Discord our chat application where you can ask directly to Brian more questions.
Definitely, I will be in the chat application for at least another 30 minutes. So if you have questions, feel free to ask the questions in the chat, or ping me on Twitter, or well, when we're allowed to see each other again on an event, just give me a push and say, Brian, I want to talk to you about something. I'm always in for a discussion on that. I want to thank Jay Spring for getting me in. Amazing for doing this. Urs, thank you so much for hosting this.
Thanks too.
All right. See you later.